Hello, everyone. Thanks for joining today for another episode of Open Cluster Management Community Meeting. Once again, we're excited to have Steven from Submariner.io team to do a demo of their product. And later on, we'll have Ku Zhang to talk about the add-on framework for Open Cluster Management. But first, let's hand it over to the Submariner.io folks. So without further delay, please take it away, Steven. Steven?
Yeah, sorry. My connection was a bit iffy there. So what was the question?
Oh, no, I thought you were going to do a little demonstration of the Submariner.
Yep.
Yep, go ahead.
Yeah. So all right, here we go.
Recording is on.
Can everybody see my K9S screen? Yeah. Okay, so Submariner provides connectivity between Kubernetes clusters. So I've set up 3 clusters here that I'll be using for the demo. The first one is a small one with just a control plane and a worker node. The second one has 2 worker nodes, same for the third one, and this is the standard setup that we use for our end-to-end tests. So you can set it up with, from the Submariner project, there's a make command, which is make clusters, like that, and I set it up with Prometheus. So this is what I ran. And so just to prove that I haven't set anything else up yet, so we will see Submariner being set up. These are the pods that are running. There's just the standard Kubernetes plus Prometheus. And likewise here on cluster 2, plus some pods that I installed for just to test connectivity, and likewise on cluster 3. And so the first thing is because Submariner is supposed to provide connectivity, let's check that we don't yet have connectivity. So I have, like I just mentioned, a few pods that I'm going to be using for tests. We have one that's a NetShoot pod. So I'll store its pod name here. And then we have another one on cluster 3. And Nginx pods that are running on cluster 2. So as you might expect, if we run curl, try and talk to the Nginx service from cluster 2, so this is what I'm going to do here, kubectl context cluster 2, and we're executing in the NetShoot 2 pod and talking to Nginx on cluster 2, and it gets the default homepage back, and the same again if we do it with the service name. But if we try to do that from cluster 3, talking to cluster 2, so I've added a timeout here so that we don't wait too long. It can't connect. So there's no data plane connectivity. And if we try to use the service name, it can't resolve the host. So cluster 3 doesn't know about the service on cluster 2 at all. So let's install Submariner. And this isn't how it works in ACM. ACM uses a different tool, but I'll show how to do it using Subcuttle. So first you install it. So this is the latest release, version 0.8.0, just to check again. There we go. And the first step is to set up the broker. So the broker is just a set of CRDs that we're going to install in cluster 1. And we can keep an eye on that. If I go and look at the CRDs on cluster 1, currently we only have the Prometheus CRDs. And these CRDs will be used to store information about all the clusters that are connected together. And there's no code actually running for Submariner itself on the broker. It's just data storage. So let's run that. We can watch it here. See all the CRDs with in the Submariner.io namespace. So clusters, the cluster CRD stores information about all the clusters that are connected. This is fairly basic. The CIDRs that are involved, an ID. There's a color code you can see in there, but you can ignore that because it's not useful currently. And the GlobalNet CRD, I'll come back to that later. The service CIDR, sorry, the service CIDR as well. Then there's the endpoints CRD. This is used to store information about the hosts that we can actually use to connect to each different cluster. So for example, on cluster 2, we'll have a gateway node, and this will appear in the endpoints here, and that way cluster 3 will know how to connect to cluster 2. Gateways, this is our sort of status object. I'll show that later on. And then further down here, we have service imports. So the Lighthouse one is a legacy variant that will be going away soon. And the multicluster.xk version is the version from the MCS API. So this is something that we're working on with the MCS SIG upstream. And these are used to store information about the services that are made available from one cluster to another. And I'll come back to that later again. And so another thing that Subcuttle Deploy Broker does is it stores information about the broker in a file called broker-info.subm, and this stores the address of the API endpoints that are used to talk to the broker, and also the configuration settings that were used, and authentication tokens, so that we can just pass this file around to join the clusters to the broker. So let's go ahead and do that. I'll start with cluster 2. So here I say subcuttle join. In the context cluster 2, I'm disabling NAT traversal because we don't need it for this demo, but for example on AWS you would. And I give it the name of the broker info subm file. So let's go and see what's going to happen here. This is mostly about pods, so yeah, I was already on the pods view. Let's start that. And the first step is, because I have 2 worker nodes, I need to choose one that will act as the gateway. I could specify that both would serve as gateways, and then we'd have a fallback. If one gateway stops working, then Submariner will switch to the other. So now you can see here, we have Submariner operator that's appeared, and it's going to start deploying a bunch of other pods. A gateway pod, Lighthouse agent, this is for service discovery, Lighthouse core DNS for service discovery as well, and the root agent. So the gateway pod is used on the gateway node, and it handles the actual tunnels that we'll be setting up between the clusters. The root agents, they run on all the nodes, and they redirect traffic to the gateway node as appropriate. And Lighthouse, like I said, is for service discovery, but I'll come back to that. Then we can join cluster 3. And same again, I need to choose a node. So while that's happening, I'll go back and we can have a look at the CRDs, the CRs that are being stored in the broker itself. So if we go and look in the clusters CRD, eventually, there we go, cluster 2 will show up. And so this just says, it just gives the cluster ID, cluster CIDR, and we'll also have an endpoint that matches that. Sorry. Oh. Nope. Oh well. I'll show you another way of getting that later. But Submariner, the cluster 3 is up and running now as well, so we can go and have a look at the pods that are coming up here, slowly but surely. And the cluster will show up on cluster 1 as well once it's up and running. There we have the gateway up. The root agents are nearly up. So it shouldn't take too long now. There we go. So now that we have both the cluster updates here, we know that the two clusters are connected. So if we try the Nginx test that I ran earlier again, this is connecting from cluster 3 using the IP address, and that works. So now we have data plane connectivity between the two clusters, but we won't have service connectivity yet. On cluster 3 still doesn't know about the Nginx demo service on cluster 2. So let's fix that using Lighthouse. And again, using subcuttle, there's an export command, export service, and we're exporting the Nginx demo and running on cluster 2, which is where the Nginx demo service lives. That's it. And so what that does is it creates a service export object on cluster 2, and the Lighthouse agent creates a corresponding service import and synchronizes that with the gateway. So we can actually go and see this here eventually. So and then run the test again. With, you might notice, a slightly different address. So I'm not just saying Nginx demo here. I have to say, I have to use a separate domain, which is clusterset.local, and then we use the service subdomain underneath that, the default namespace, and Nginx demo. There we go. So now cluster 3 knows about the service on cluster 2. I'm not sure why it's not showing up on cluster 1. I'll need to check that. Right, so that's the basic connectivity and service exports. I mentioned earlier that we'd look at the information that's available about the clusters as well. So there's a series of subcuttle show commands that we can use. So here is on cluster 2, and so there we see the network details that were discovered about cluster 2, the cluster IDs that cluster 2 knows about, so itself, and cluster 3, with their endpoint IPs, the cable driver that's used. So Submariner currently supports LibreSwan for IPsec and WireGuard as well. The gateway status, So this shows the connection between cluster 2 and cluster 3, and it says it's connected. And right, so Laura has a question. Do the service exports and imports need to be stored in the broker? I guess you might be looking at the wrong cluster. So yeah, well, I can, if we go and look at cluster 2, we'll see the service export. No, but I suspect I've got something wrong in my K9S setup. But what happens is there's a service export on cluster 2 that gets translated into a service import synchronized with the broker, and then that's how cluster 3 gets it, because cluster 2 doesn't send the service exports and imports directly to to cluster 3. It goes through the broker. So yeah, so they do have to live on, well, the imports themselves have to live on the broker. The exports aren't synchronized, but the imports are. So going back to show all, we also have the nodes that are used as gateways, and then the versions of all the components that we're running. And we can do the same on cluster 3, and we see the same information there. We can also get there are a couple of commands that can be used to run benchmarks. Sorry, that's not that one. Both latency and throughput, but they take some time to run, so I'll just stop them. But there's another nice feature that we have regarding latency, at least, which is that we keep track of the latency that we're measuring all the time through the tunnels. And so if you go and look at the gateway object in each cluster, which gives the status of the Submariner setup on each cluster, we can see here latency RTT. So it measures the average latency standard deviation and the min and max that we've seen and the last time it was measured. So here we're looking at an average of 635 microseconds between the two clusters, and that's updated all the time. Same again on cluster 3, which is measuring a slightly lower latency right now. And we also have the last feature in subcuttle for the time being is that, well, because we build all our end-to-end tests in Go, it's fairly easy to just include them in subcuttle, which is written in Go itself. And so you can actually run, using subcuttle, all our end-to-end tests on any pair of clusters that are connected. And so this can be useful for troubleshooting, etc. And so that's it for everything I'd planned for the demo. But if there are any questions, we can look into.
Thank you, Stephen. Are there any?
Yeah, you're welcome.
Regarding the Submariner.io? Okay, I guess not. Thank you so much, Stephen. That was awesome, especially with the benchmark. Kujan is going to talk about the add-on framework for the operator for the open cluster management. Kujan, could you please take it away? Thank you.
Okay. Let me share my screen. So I think so. This one is more is not basically an existing things in the open cluster management, but some ideas that we are proposing, and we want to get any feedbacks that whether you think that makes sense, or I mean, feel free to drop any comments in the doc that has a link here. The basic idea here is that so from the basic of the open cluster management, we have the two basic component that is registration for the cluster register to a hub and a manifest work API to help to distribute the manifest resources to a certain cluster. So with that, we are thinking whether we could extend by using these APIs to extend to develop extensions upon the registration and the work. So this is a simple diagram that there is two parts. The basic part is the registration and the work, and above that, we want to check whether we want to think like whether we could be able to develop a set of the add-ons that for the different functions to manage the multi-clusters. So one of the example is Submariner. For example, for the Submariner, it has a broker that also run in the hub, and there will be Submariner's component like Submariner agent. Those will be running on the cluster, managed clusters, and so we should be able to using the to take the Submariner as an add-on up based on the registration and work. So currently we have two APIs in the alpha stage in the API repo. One is called Cluster Manager add-on and Managed Cluster add-on. So these two APIs is basically for the purpose of this to support the customized add-ons for the different functions. So the first thing that we want to define is like what is an add-on. How do we say a workload that deployed on managed cluster is an add-on? So we have several conditions. One is that at first this workload or the manifest should be run on the managed cluster, and the second one is it should talk to the hub with a certain permissions. For example, in Submariner cases, the Submariner agent will talk to the broker in the hub to distribute information among the different clusters. And we could think of other agent like, for example, another possible agent is that another possible add-on is that we could collect some informations in the managed cluster and have a centralized database on the hub that the agent on the clusters could send the informations back to the database on the hub. So these are some examples of the add-ons. So with that, we are thinking that we could have a standard procedures based on these two APIs, the Cluster Manager add-on and Managed Cluster add-on APIs. For this doc, the objective is that we want to have a standard procedure that when an add-on could be registered to the hub and how we can enable an add-on agent that to be installed on the managed cluster. And we want to propose a framework or a Golang interface that could help to make the add-on development easier. So for the procedure of the add-on registration, there may be two basic steps. The first step is that, for example, at first the cluster admin will going to deploy add-on controllers on the hub, and then the add-on controller itself will register itself to the hub by creating a cluster manager add-on resource on the hub. For example, taking Submariner as a use case, the Submariner's add-on controller will register itself as a Submariner on the cluster management add-on resource. And then when a user trying to, let's say when a user has two clusters and the user want to to enable the add-on agent on each of the clusters, the user need to create a managed cluster add-on resource on each namespace of the clusters. For example, if we have cluster 1 and in the namespace of cluster 1, the user will create a managed cluster add-on. The name of the add-on will be the same name of the cluster management add-on. In that case, we could be able to link the two to know that which agent should be deployed on the managed cluster. And with that, we can use things like manifest work to deploy the agent. And also we can have some mechanism to help to register, to define a registration procedure that the agent could use MTLS to register back with like certificate rotation. So I think if we can have a standard procedure like this, we would be able to have an interface defined. So this is just an example in my prototype that in my own repo here. That is, we can have an interface to define that there's an add-on manager. You can enable that. You can start a new add-on manager that will manage a certain add-on, and with that we can define whether we want to enable the registration. That means that we want the add-on to be able to register to the hub with CSR and be able to do the certificate rotation using the CSR. And there is some other things like we can define how the CSRs can be approved in the hub, and then we can start the add-on manager. So there is an interface for the add-on manager that will be implemented. It's called agent add-on. And the agent add-on interface will probably include two methods. One method is to define the manifests or the manifest resources that is going to be deployed on a certain cluster. So it takes the cluster as an input, and it can take additional configuration defined by separate CRs, and then the user could develop this method and then return a set of the object, and this object will be put into the manifest work and to ensure that these things will be installed on the managed cluster. A simple example is that, for example, if our agent add-on agent includes a service account and deployment and a set of permissions, this list of the object will include things like deployment service account cluster role and cluster role bindings. And the add-on manager will use this method to get the set of resources and put into the manifest work to ensure that these resources is being deployed on the certain cluster. And another part is about the permission for the agent. So for each agent, there is another method that you'll need to implement is the RBAC permissions for the agent on the hub. For example, if you have an agent that have a certain that's going to register back to the hub with a certain identity, we need to give the agent a certain permissions for a set of the resources. So here, it will return the role and role bindings for the agent on the hub, and then the manager will create this role and role binding on the hub for each agent. I think that's about the doc, and I did some prototype here. Like if we really want to do some things like that, a simple way is, for example, we have agent definition that including the deployment, the service content cluster role bindings. So this part will be the part that is going to be deployed on the managed cluster, and there are also the role and role bindings for the agent on the hub, and then we can define the agent by create the agent by implementing the agent interface and put the manifest role and role bindings, and then start an add-on manager. So since we want the agent to be registered back with a CSR, we also have the with registration enabled and with CSR approved func. So here you can define different CSR approved functions. Here for simplicity, we just define like we approve all the CSRs that has been returned by the agent. So here is an example. So based on that, we can build an controller, add-on controllers. And when I started, we should be able to see that there is a cluster management add-on that is being registered on the hub with the name of foundation. So this is just an example. And then we in the cluster one, because we have a cluster one managed cluster, cluster one, and then we can create a cluster add-on manage cluster add-on resources on the cluster one namespace. Okay, so then with that, you should be able to see two manifest work being created on the cluster one. One is to deploy the registration agent that will going to start to register back to the hub and provide a secret, which actually a hub config secret that can be used by the another part. It is the real foundation agent. So if we see the agent registration agent manifest work, it is like there is a cluster row bindings in this and the deployment that is going to say this is the add-on name is foundation and we want to register back. And if it works, there should be an CSR. Okay, the CSR is created here, and because we set auto approve always to be true, and this one will be approved, and then which means that the add-on agent is registered correctly back to the hub, and then the agent should be able to connect back to the hub. Yeah, so I think that's all for this. I think this is still in my private repo, and still we're still prototyping it. And I mean, if there is any comments, any feedback for the doc and for the code, I mean, feel free to drop any comments here. So yeah, any questions for this?
So question, Pujan, so if I were to use your framework and I create a add-on,
Mm.
I don't actually need I can incorporate into the Server Foundation runtime already. So I don't need the whatever is running in your private repo to get it all working. The private repo part is just to generate the add-on easier, right? Or do I still need the whatever's in your private repo for all this to work?
So this one is just to provide a library, and for the other add-on that tries to implement it, as here need to implement this manager library and the interface library, and then basically the add-on library, the manager add-on library, and then implement the agent interface and put. So this is a code that has to be put into the controller that is going to implement an add-on to be deployed on the managed cluster.
Okay, thank you. Are there any other questions for QJ? Well, if not, then thank you everyone for attending again. Thanks for the amazing demonstration, Stephen and QJ. Take care, everyone.